But notice we had monomials, well, in our denominator. Now we're going to look at what we do when we have a binomial in the denominator. Well, the first thing we have to understand is something called complex conjugates. And conjugates are going to be used, and they're just a very big word, but they're a very simple concept. So the conjugate, for an example, here's what a conjugate is. The conjugate of a plus bi is simply a minus bi. So whatever I have here as a stays. Whatever I have here as bi stays. But I will change my signs. All that I do is I just change the signs in the middle. That's it. Everything else stays the same. And then we're going to see why we do a conjugate. So I want you to look at this first example of conjugates. Notice my 5 and my 5 are the same. My 2i and my 2i are the same. Like no numbers change, nothing else changes. All that is different are the two signs, one positive, one negative. Okay? That is the key thing to a conjugate. Now let's show you why we use conjugates, why they're effective. So I'm going to go ahead and distribute or FOIL. As I've said in the past, we're going to distribute this through. So the 5 is going to distribute through to everything. So 5 times 5 is 25. And 5 times negative 2i is negative 10i. Okay, and then I'm going to distribute the positive 2i. So 2i times 5 is positive 10i. And then 2i times negative 2i. Well, 2 times negative 2 is negative 4. And I times I is I squared. So notice when we do combining our like terms, negative 10i and positive 10i, look what happens to those. They add to 0. So then we get 25 minus 4 times negative 1 because my I squared is negative 1. Well, negative 4 times negative 1 becomes 25 plus 4. So look what happens. I multiply those conjugates together and I end up with a real number. In other words, there is no I, no imaginary number. It's a way to eliminate that I part, that imaginary number part. So notice in this one again, the 7s are the same. The 3 I's are the same, but all that's different is my first parentheses has a minus, so the conjugate of that would just be with a plus. That's as simple as I can make it. So let's multiply. 7 times 7 is 49. 7 times 3i is positive 21i. Negative 3i times 7 is negative 21i. And then negative 3i times positive 3i would be negative 9i squared. So I end up with 49. These add to 0 minus 9 times negative 1, which gives me 49 plus 9 instead of minus 9. And I end up with 58. Okay, so my I just goes away. So we're going to use conjugates now to get our denominators to not have an I. So we're going to take it again, one more step. Okay, so the conjugate of 1 minus 2i would simply be 1 plus 2i. And whatever I multiply my denominator by, I have to multiply my numerator by the same thing. So now I've got lots of binomial multiplication going on. So I'm sorry this is so difficult. Let's go ahead and focus on the numerator first. Okay, actually I'm going to raise it up a little bit because I write so big I need the space. So let's focus on our numerator first. So 4 times 1 is 4. 4 times 2i is positive 8i. 3i times 1 is positive 3i. And then 3i times 2i is positive 6i squared. Now, the numerator, these are not conjugates, so my I is not going to disappear. I'm going to have an imaginary part in my numerator, and that is okay. But let's do the denominator. I'm going to do the denominator in a different color. So 1 times 1 is 1. I have positive 2i and negative 2i. I'm going to go ahead and do those, but the next time I'm not, because we know if we've done our conjugate correctly, they're going to eliminate. And then negative 2i times positive 2i would be negative 4i squared. So let's combine all of our like terms in our numerator. So we have 4, and we have 8i plus 3i is positive 11i. And then I have positive 6 times negative 1. Okay, my denominator, well, that adds to 0. So I get 1 minus 4 times negative 1. So there's my denominator. So you guys, positive 6, let's focus now on my numerator. So right here, positive 6 times negative 1 becomes a negative 6. So I'm going to put my 4 and my negative 6 together. And 4 and negative 6 is negative 2 plus 11i. Okay, and then I'm going to go ahead and my negative 4 and negative 1 make a positive 4. So I end up with 1 plus 4. So I have, okay. The last problem we're going to do, just one more. So I'm going to multiply by the conjugate. So the conjugate of this would be simply 4 minus 2i. I don't care if the 4 in front is negative or positive. It doesn't matter what the number in front is. If the number is negative, just keep it. Just change the sign in the middle. Change the sign in the middle. And don't forget, binomials times binomials, we have to distribute everything. So again, I'm going to do my numerator first. 3 times 4 is 12. 3 times negative 2i, negative 6i. So I did those two. So now I'm going to do 5i times 4, and I get positive 20i. And then 5i times negative 2i, negative 10i squared. Pay attention, that very last one should be an I squared. If you have two i's, you should somehow end up with an I squared. Okay, let's do the denominator. So 4 times 4 is 16. My negative 2, or excuse me, 4 times my negative 8i, my positive 8i are going to cancel out. So then 2i times negative 2i is negative 4i squared. I told you I was going to skip that middle part because we should know if we've done a conjugate, that middle part is going to cancel out. So let's simplify my numerator. I get 12. Negative 6i plus 20i is positive 14i minus 10 times negative 1. And then down here I've got 16 minus 4 times negative 1. Okay, last little step. My negative 10 and negative 1 multiply together to make a positive 10. So 12 plus 10 is 22 plus 14i. And then down here, my 16 plus 4 becomes 20. Okay? Now, I'm looking at my 22, my 14, and my 20. They all are even and can be divided by 2. So I'm going to divide them each by 2. So 22 divided by 2 is 11. 14 divided by 2 is 7. And 20 divided by 2 is 10. Simplified answer.